So, chapter 20, the heart. Few extra slides, more slides than the other one, but guess what? We're starting it today, not next week. Even better. And if you looked at next week's schedule, whoa, packed, quiz, test, quiz, yeah, labs. We're booked next week. Next week, fatness. Nothing but fatness. Yeah. Yeah, we start Monday off with a quiz, then we go into Wednesday with a test, and then we go into Friday with another quiz. Okay? And unbelievably, I'm going to go ahead and say this right now. If you're paying attention, you're good to go. If you're not here, you might want to let your friends know. Next Friday's quiz, there's no makeups on that. You miss it, you miss it. Next Friday's quiz, there's no makeups. Okay? So, if you on Thursday, Friday's out. All right? Chapter 20, the heart. Chapter 20, the heart. Well, this chapter is by far one of the most interesting chapters, the one that students tend to relate to the best. It happens to be one of the hardest chapters, content-wise, but not physiology. Okay, it's pretty straightforward when it comes to physiology. All right, and I'll do a bunch of crazy stuff on the board for you guys for the physiology that will totally help with that. All right, so we have two circuits. We have a pulmonary circuit. Pulmonary circuit carries blood to and from gas exchange surfaces of the lungs. Well, let's just get rid of the gas exchange and just say carries blood to and from the lungs. To and from the lungs. The systemic circuit, entire system, okay, carries blood to and from the body. That's better. Blood alternates between pulmonary circuit and systemic circuit. So we go to the systemic circuit, then we go to the heart, then we go to the the pulmonary circuit, then the heart, then the systemic, then the pulmonary, then the heart, then the systemic, and we just keep doing that. We keep circling through. All right? Pulmonary or lungs. It's the circuit for the lungs. There are three types of blood vessels: arteries, veins, and capillaries. Well, we've learned a little bit about capillaries. Arteries carry blood away from the heart. That's a true statement. Veins carry blood to the heart. That's a very true statement. And capillaries are everything in between. All right, we are going to have different types of veins and arteries. We're going to have the aorta, which is a gigantic, huge artery. Okay, then we're going to have arteries. And then we're going to have these little things called arterioles. Arterioles, and all that just means a small artery. Okay, then we're going to have the vena cava, and unbelievably, vena is the actual root word for vein. It's the original root word for vein. Okay, so vena cava, we're going to have a superior and inferior. Superior, we're talking about the head. Inferior, we're talking about the body. Then we go into veins, and then because we have to have small veins, we have venules. Okay, and then everything leads into a capillary, and that's where we're going to make our exchange. Capillaries are also called, oh my goodness gracious me, exchange vessels. Why? Because stuff's going to do this. Cells, take what you need, back to the vessels. All right? So exchange material between the blood and the tissues. Okay, materials include dissolved gases, nutrients, and waste products. Now, let's back up to this word tissues. What makes up tissues? Cells. So don't just think, oh my gosh, tissues, think cells. And that's why I just said cells and not tissue. Cells make tissue. Tissue makes organs. Organs makes organ systems. Organ systems make us. You got to think small. So the exchange is actually going on at a cellular level. It includes dissolved gases, CO2 and O2, nutrients, obviously amino acids and proteins and all those other different things, vitamins and all that has to be circulated around. And then because we're producing waste, we got to get rid of it. Okay? Boom, and I have already loaded this image without the human on it for you guys online. It's already on there. Some of you have already printed it up. I didn't think we actually needed the human. I think just the image itself was good enough. But you're going to need to know this. You're also going to need to know that there are going to be some numbers we're going to add to it. Okay? It's really like that. Obviously more intricate, but that's exactly what it's like. Okay? And notice what's happening here. All right? Whoa, back up. That's what I needed. So here's our heart. Boom, out into the pulmonary circuit. Notice the pulmonary circuit. Then we come back into the heart. Then we come up into the aortic arch. This goes up to the head. This goes down to the rest of the systemic circuit down here. And then circulates right back through. The key to the physiology in this chapter is literally circulation. The key to the physiology is circulation and how the heart utilizes it. Okay? So the heart itself says, you know what? I'll take some blood for myself, but then I'll pump blood out to the body too. Okay? So, 4 chambers of the heart. There are four chambers of the heart. Start off simple. Just do this. Not too tough. 4 chambers. And remember anatomical position, please. Okay? There's your 4 chambers. Right atrium collects blood from systemic circuit. Right ventricle pumps blood to pulmonary circuit. Left atrium collects blood from pulmonary circuit. Left ventricle pumps blood to systemic circuit. All right? So, if we start off with just the chambers, there you go. Nothing crazy, pretty good. Okay? Now, what did I say about the whole A before anything? Aqueous before vitreous. Afferent before efferent. Atrial before ventricle. You have to go through the atrium first before you can go through the ventricles. Always A before something. Okay? So in this case, atrium and ventricle. Now, here's the aha moment. What is the name of the hormone that is directly related to the heart? ANP. What does that mean? Atrial natriuretic peptide. Atrium, atrial, same thing. Oh, who would have thunk it?
The other one is the brain, right?
Right?
BNP.
BNP.
Yeah.
Okay? So, right atrium, atrial just means pertaining to the atrium. Okay? So, atrial natriuretic peptide. I know, craziness how they hide that stuff. So, A before V, and then let's put some direction on it. Like this, and like that. Okay, we're going to have a valve right here, so we're going to go to the lungs. We're going to have a valve right here, which means we're going to go to the aorta. Okay, notice how it's flowing down. It's flowing down. So if it's flowing down, what do you think is going to help us with blood flow? If it's flowing down, gravity. Yeah, if it's flowing down, gravity's going to help us with blood flow from the atrium to the ventricles. All right. The heart itself, okay, great veins and arteries at the base point to the, or pointed tip is the apex. Okay, so there's the first rule that is not normal. Oh yeah. Feel the love. So what they're saying here is the pointed tip is the apex and the top is the base. What is wrong with that? It's backwards. The apex is supposed to be the top or the point, okay? And the base is supposed to be the bottom. So there's the first rule that's odd about the heart. Okay? It's backwards. This is the base and this is the apex. Now apex does mean point, but it's usually the point or top of something. So in this case, it's odd. It really is odd. Remember, I told you the heart has its own rules. It plays by its own game. Okay, so great veins and arteries at the base. So where do you think all the veins and arteries are going to be? Yeah. Right across here, mainly in the posterior aspect. Okay, now it is surrounded by a pericardial sac. We've already learned about this because this was in 241, right? Coverings and linings, you guys remember that? Coverings and linings? Okay, site between two pleural cavities in the mediastinum. Well, we learned about spaces, and you guys already know this, okay? You already know this, right? You know that we have the thoracic cavity, and in the thoracic cavity we have the pleural cavity and the mediastinum. In the mediastinum we have the pericardial cavity. You guys remember all that? Start to refresh our memories. Yahoo! Okay, abdominal pelvic cavity. Well, we're talking about visceral organs now. So we know where the heart lies, site between two pleural cavities, the lungs, pleural cavities, okay, in the mediastinum, right down the middle here. Whoa, and there you go. Okay, pretty cool picture, I like it. You should like it too. It's good to know, good to note, good to understand. Notice the diaphragm. That means the heart actually sits right on top of the diaphragm. Just kapah, right there. So do the lungs. Kapah. Just, yeah. All right? Okay, all of our covering terminology applies here. So we have the parietal, we have the visceral, pericardial. All of that applies. You know, same stuff from 241. We're just bringing it back here for 242. So the pericardium, double lining, pericardial cavity, visceral, and parietal. Visceral and parietal pericardium. And everybody knows why we have that sac, because the heart does this. Boom, 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 boom. So the sac needs to do this. Squeak, 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 squeak. There you go. And if you're in love, it's not bump, bump, it's love, dub. Love, dub. Okay, that's where that came from. The whole love, dub, the sounds of the heart. That's because you're in love. And it's perfect because it's springtime too, right? Birds, bees, you and your special someone laying in the lawn, hold each other's hands, blinking at each other, creating tears. Yeah, crazy. Pericardium, well, pericardial cavity, parietal visceral layers, and it does contain pericardial fluid. Okay, this is the fluid that reduces friction when the heart beats. It does stabilize the heart and also, unbelievably, helps prevent overflowing, overbeating. Okay, this is a top view, horrible view. Horrible. Like, yeah, looking at that, that makes you dizzy. If you have vertigo, you're falling. Okay, notice the fist and the sac for the heart. There's an opening at the top. There's your balloon that they're using as an example. Okay, so literally it's the same unit, just if you put your fist through a balloon, it has an outer layer and an inner layer. It's still the same covering. That's why it's called a pericardium, because it has a visceral and parietal layer. Okay, so that notice how it's covering the heart. There's the double layer right there. So this is nothing new. We should be, having flashbacks of 241. Superficial anatomy of the heart. Well, the atria. Atria, it's thin wall, expandable outer auricles. Auricles, also known as dog ears. Yeah, I know. Dog ears, like dog. Dog ears. Okay? Yeah. Why? Because literally when you look at it on the heart, they actually flap down like this. Okay? And when they fill up, they do this. And then back down again. Yeah. Kind of like a dog when you say treat. Huh? Yeah, they get excited. Craziness. All right, superficial anatomy of the heart. Well, sulci. What's a sulci? Oh.
Shooting, right?
Huh? It's a small fissure, right? You guys are you guys like tipping the tongue. That's so awesome. Yeah. Yeah. Okay, so coronary sulcus divides the atria and ventricles. Anterior interventricular sulcus and posterior interventricular sulcus should not scare you. Enter between the ventricles. Between the ventricles. That's all it's saying. It's a sulcus that's found between the ventricles. So, check this noise out. You guys are going to love this. Here's my heart. Okay? Let's label it out. Right atrium, left atrium, right ventricle, left ventricle. Is everybody with me now? And this is saying on the outside, the anterior and posterior view of the heart, superficial, there's actually a line like this. And that line separates the what? The right and left ventricles. That's on the outside of the heart, so not a big deal. But it separates the ventricles. It contains blood vessels for cardiac muscle. Well, the heart is muscle, so it needs blood vessels to work. And these are the blood vessels that feed the heart. That's on the outside, the superficial. Okay? Anterior interventricular sulcus and posterior interventricular sulcus. It's all about dividing lines, and you can visually see these on the outside of it. Okay, there's your heart. It's the location of it. Notice it's right over, or actually right under, excuse me, just deep to the, what is this? Sternum. Okay, and this little chunk of bone right up here? The what? Right here, it's connected to the sternum. Starts with an M. Manubrium. Manubrium. She got everybody. Jessica's like, it starts with an M. Everybody Manubrium. Yeah. How about this little guy right here? Xiphoid process. Yeah, fantastic. So what they're saying here is when you do compressions to pump blood through someone's body, you're pressing on this section. Okay, the body of the sternum, and because you're depressing that, you're depressing the heart. Okay? Don't go too low because this will break off and puncture something. That would be horrible. Not good. It doesn't matter anyways, because guess what? When you make your first compression right there, guess what happens? All of the cartilage separates. So, and then it's quiet afterwards. Oh yeah. Yeah, the first time I ever did compressions on someone, they're like, start compressions. I'm like, oh yeah, it was freaky. It was freaky. And of course the doctor did this to me. The doctor was awesome. He goes like this, he goes, Philip, slow down. I was the one that's having a problem. And I'm like, oh. Yeah, it's crazy. It's crazy. The first time you ever do it, are you breathing for someone? Yeah, you got the Ambu bag? Think about how we breathe. You're doing this. Who to save them? They're blowing up like a balloon, and you're like, yeah, craziness. And there's the reasoning behind your positioning for doing compressions. Okay, there's the heart. Ooh, beautiful. Lovely. Okay, notice the right atrium, right ventricle. Okay, the Auricle, kind of a dog ear flap right there, and a dog ear flap right there. Okay, they literally do flap over like this. I was not kidding. Okay, pretty good. This is mainly the exterior surface. I'm more concerned with the interior surface. In fact, if you look at your weekly schedule, guess what's on it? A picture of the interior surface of the heart. Yes, sir, Bobberoni. That's a real heart. That just looks lovely. It's preserved, don't worry. But that's not what your heart looks like. You're probably panicking right now. Okay? Posterior aspect of the heart. Notice you got a little bit of fat on there. Your heart needs a little bit of fat, not too much. All right? Notice all the vessels are pointing in the posterior aspect. Another aha moment. Most people think everything comes up right here. Well, most of it does, but it immediately turns around and goes back. Do we have room to come forward? No. No, your heart's literally right there. So we have to go backwards. Everything has to go back. And we go back and drop down. Now, I recommend everybody trying this. Just don't go overboard, okay? If you have a special someone or a friend that's not afraid of you touching their stomach, okay? Have them lay down on a flat surface. Take your hand flat. Put it just above their belly button, right about here, and depress down. Okay? You just depress down on it. What you're going to feel is that's your descending aorta. You're actually going to feel their heart beat through that vessel. Not up here, but down here. Yep. So make sure they're on a flat surface, hard flat surface, not on the bed, on the floor, and depress it down. Don't make them vomit on you, but just put enough pressure and you'll actually feel that aorta pulse underneath there. Okay, it's pretty cool. Okay, walls, epi, myo, and endo. Okay, endo, inside. It's continuous with the blood vessels. Myo means muscle. Yeah, it's just the muscle of the heart. That's all it is. And then epi is unbelievably your visceral and parietal layers of the pericardium. Epi, visceral pericardium. There you go. Okay, they're synonymous with each other. People actually use them hand in hand. They won't actually change them. So myocardium, middle, that's all about heart. And then endocardium, we're talking about simple squamous epithelium that lines the inside of the heart that actually moves out. Oh dear. You guys are like, no, we were done. We paid our dues last quarter. No, you didn't. It's here to haunt you. Simple squamous epithelium of the endocardium, which is seamless with the blood vessels. It actually goes right out of the heart and right into the blood vessels. Okay? So endothelium in the blood vessels, endocardium in the heart. We just talked about endothelium because what did we talk about in blood? Damaged blood vessels. Okay? So there you go. Showing you the layers of the heart. Pretty good layout. That's not a bad layout at all. So please make sure you understand these different areas of the heart. Okay? Our little covering. Notice our simple squamous right here. Yay. It's pretty awesome. The heart muscles. Notice how they wrap around the heart. What do they have to do? Squeeze, squeeze. Squeeze, squeeze. Notice the top squeeze is pretty wimpy. Squeeze, squeeze. Well, because this has more muscle, actually other way around. The left side has more muscle, and the right side has muscle, but not as much. The left side's pumping out to the entire body, so we've really got to squeeze. As where the right side's pumping to the lungs. We don't want to force too much blood. Same volume, though. Same amount of blood going to the body and to the lungs. The difference is this has got more force of contraction than this. But they still do this. Squeeze, squeeze. And that's because it's actually pumping down and then out. Down and out. And in this diagram, is that correct? Down and out. Any questions? Like I said, this is where it gets fun. You guys actually are perking up. You're like, whoa, hard? Yeah. All right? How's your hands, your right hands? Are they surviving? Are they recovering? The blood's starting to go back where it belongs? I know that was the hardest workout you guys had in a while, and it's okay. Unless you play guitar. And then you, yeah. All right, no questions, I'll see you guys on Monday. Please check your weekly schedule.